Hello everyone. Today we'll study quadratic equations. A quadratic equation is a second degree equation. That's called quadratic equation. Second degree equation is called quadratic equation. First of all, let me show you how to solve quadratic equations by factoring. First example, x squared minus 6x plus 4 equals 0. How can we solve this equation by factoring? If we look at the left side of the equation, we can see that this is a trinomial and there's no leading coefficient. So I can draw two parentheses. Put x on each parentheses and then try to find two numbers that when we multiply we get 5. When we add we get negative 6. We can try. 1 times 5 is 5. But we want to get negative 6 here. So we can use negative 1, negative 5. Negative 1 times negative 5 is positive 5. And negative 1 plus negative 5 is negative 6. So these two numbers works. We write x minus 1 and x minus 5 in the parentheses. Then, when two factors multiply to be 0, we set both of them equal to 0. Set x minus 1 equal to 0 and set x minus 5 equal to 0. Solve an equation for x. In the first equation, I can add 1 to both sides. I get x equal to 1. In the second equation, I can add 5 to both sides. I get x equal to 5. So those are the solutions to this equation. Those are the solutions to this quadratic equation. Next example, x squared plus 4x minus 12 equals 0. How can we solve this equation by factoring? Same thing. On the left side, this is a trinomial with no leading coefficient. So draw two parentheses. Put x on each parentheses. Then try to find two numbers that when we multiply we get negative 12. When we add we get positive 4. We know that 2 times 6 is 12. If I make negative 2 and positive 6 here, negative 2 times positive 6 is negative 12. And negative 2 plus positive 6 is positive 4. So I can put these two numbers in the parentheses. Write x minus 2 and x plus 6. Set equal 0. When two factors multiply to be 0, set each of them equal to 0. So we set x minus 2 equal to 0 and x plus 6 equal to 0. In the first equation, I can add 2 to both sides. I get x equal to 2. In the second equation, I can subtract 6 from both sides. I get x equal to negative 6. So those are the solutions to this equation. Next example, x squared plus ax plus 16 equal to 0. X squared plus ax plus 16 equal to 0. How can we solve this equation by factoring? Again, this is a trinomial with no leading coefficients. So write two parentheses, put x on each parentheses. Then try to find two numbers that when we multiply we get 16. When we add we get positive a. Here we can try 4 and 4. We know that 4 times 4 is 16 and 4 plus 4 is 8. So we write x plus 4, x plus 4. Now here, that's a special case. If both factors looks exactly the same, we write x plus 4 squared equal to 0. Then, if x plus 4 squared equal to 0, I can take square root on both sides. I get x plus 4 equal to 0. Square root of 0 is 0. Then I can subtract 4 from both sides. I get x equal to minus 4. That's a solution to this equation. Next example, x squared minus 4x plus 4 equal to 0. How can we solve this equation by factoring? This is a trinomial with no leading coefficient, so we can draw two parentheses. Write x on each parentheses. Then try to find two numbers that when we multiply we get 4. When we add we get negative 4. We can try 2 and 2. Now 2 times 2 is 4. But we should get negative 4 as when we add the numbers. So we can try negative 2 and negative 2. Negative 2 times negative 2 is positive 4. And negative 2 plus negative 2 is negative 4. So these two numbers works. Put these two numbers in the parentheses. Then if these two factors looks exactly the same, write it as x minus 2 squared. If these two factors looks exactly the same, write it as s minus 2 squared. Then take square root on both sides. Square root of 0 is 0. We get s minus 2 equal to 0. Then I can add 2 to both sides. If I add 2 to both sides, I get s equal to 2. That's the solution to this equation. Next example, 2x squared plus 7x plus 6 equal to 0. How can we solve this equation by factoring? When there is a leading coefficient, we can try to use AC method. These three coefficients are called A, B, C. If I multiply AC, what do I get? 2 times 6 is 12. Then try to find two numbers so that when we multiply, we get 12. When we add, we get 7. Here we can try to use positive 3 and positive 4. When we multiply, we get 12. When we add, we get positive 7. Then rewrite the middle term using these two numbers. Write 7x as 3x plus 4x. Rewrite the middle term using these two numbers. Write 7x as 3x plus 4x. Then, when we get 4 terms, factor by grouping. For the first 2 terms, take our common factor, which is x. If I pull out x, what's left is 2x plus 3. For the second half, I can take out positive 2. If I pull out 2, I get 2x plus 3 equal to 0. Then, we can see that here, 2x plus 3 is a common factor. 2x plus 3 is a common factor. If I pull out 2x plus 3, what's left is x plus 2. If I pull out 2x plus 3, what's left is x plus 2. Then, that's how we factor this trinomial. When two factors multiply to be 0, set each factor equal to 0. Set 2x plus 2 equal to 0, and set x plus 2 equal to 0. For the first equation, I can subtract 3 from both sides. I get 2x equal to negative 3. And then I can divide both sides by 2. I get s equal to negative 3 over 2. For the second equation, I can subtract 2 from both sides. I get s equal to negative 2. So those are the solutions to this equation. Next example, 4x squared minus ax minus 4 equal to 0. How can we solve this equation by factoring? On the left side, this is a trinomial with a leading coefficient. So you can try to factor using AC method. These three numbers, they are called A, B, and C. Here A is 4, B is negative 8, C is negative 5. A is 4, B is negative 8, C is negative 5. Factor using AC method. If I multiply AC, 4 times negative 5 is negative 20. Next, find two numbers that when we multiply, we get negative 20. When we add, we get negative 8. We can try to use negative 10 and positive 2. When we multiply, we get negative 20. When we add, we get negative 8. Then, rewrite the middle term using these two numbers. In the middle, negative ax can be written as negative 10x plus 2x minus 5 to 0. Rewrite the middle term using these two numbers. Write negative ax as negative 10x plus 2x. Now we get 4 terms. We can factor by grouping. For the first 2 terms, take our common factor. For 4 and 10, 2 is a common factor. Also, x is a common factor. If I pull out 2x, what's left here? 4 divided by 2 is 2. X squared means there are 2x. If I pull out 1 of an x, then there another x left here. Negative 10 divided by 2 is negative 5. There's only 1 x. If I pull out x, no x left. For the second half, for 2 and 5, the only common factor is 1. If I pull out 1, what's left is 2x minus 5 equal to 0. Now, here we can see that 2x minus 5 is a common factor. If I pull out 2x minus 5, what's left is 2x plus 1. If I pull out a common factor 2x minus 5, what's left is 2x plus 1. Once we get two factors that multiply to be 0, we set each of them equal to 0. Set 2x minus 5 to 0 and 2x plus 1 to 0. Then solve each equation individually. For the first equation, I can add 5 to both sides. Then make 2x equal to 5. Then I can divide both sides by 2. I get s equal to 5 over 2. For the second equation, I can first subtract 1 from both sides. I get 2s might equal to minus 1. Then I can divide both sides by 2. I get s equal to negative 1 over 2. Those are the solutions to this equation. In general, to solve an equation by factoring, that's the simplest way to solve an equation. However, it doesn't always work. In many situations, the equations are either not factorable or it's very, very hard to factor. In this situation, we can try to solve the equation by completing squares. Next, let me show you some examples. First example, s squared minus 4 equals 0. Here we can see that this equation is not factorable. What we can try here is, we can try to add 4 to both sides. If I add 4 to both sides, I get s squared equal to 5. Once I get s squared equal to 5, I can take square root on both sides. When I take square root, I need to add plus or minus sign. So s could be either positive square root of 5 or negative square root of 5. When we take square root, always add plus or minus sign. So if s squared is 5, x is positive or negative square root of 5. So there are two solutions. S equal to square root of 5 or s equal to negative square root of 5. There are two solutions to this equation. Next example, s squared minus a equal to 0. Since this equation is not factorable, what we can try is I can try to add a to both sides. If I add a to both sides, I get s squared equal to 8. Then I can take square root on both sides. When I take square root, always add plus or minus sign. Now, can we reduce square root of a? Square root of a can be rewritten as square root of 4 times square root of 2. Square root of 4 is 2. Square root of 2 cannot be reduced, leave it the way it is. So square root of a is 2 square root of 2. So s equal to positive or negative 2 square root of 2. Which means s could be either positive 2 square root of 2 or s could be negative 2 square root of 2. There are two solutions to this equation. We must write an answer in the simplest form. So square root of a, it must be reduced as 2 square root of 2. That's the answer to this equation. Next example, s squared plus 4 equal to 0. How can we solve this equation? For this equation, I can first of all subtract 4 from both sides. If I subtract 4 from both sides, I have s squared equal to negative 4. Then, in order to get s by itself, take square root on both sides. I get s equal to plus or minus square root of negative 4. What's square root of negative 4? Square root of negative 4 can be rewritten as square root of 4 times square root of negative 1. Square root of 4 is 2, and square root of negative 1 is I. So square root of negative 4 is 2i. That means s equal to positive or negative 2i. So there are two solutions. S could be either positive 2i or negative 2i. There are two solutions. Next example, s squared plus 45 equal to 0. How can we solve this equation? I can first of all subtract 45 from both sides. If I subtract 45 from both sides, I get s squared equal to negative 45. Next, in order to get s by itself, I can take square root on both sides. If I take square root, always add plus or minus sign. So s equal to positive or negative square root of negative 45. Now how do we simplify square root of negative 45? Square root of negative 45 can be rewritten as square root of 45 times square root of negative 1. Square root of 45 is not a perfect square, but I can be rewrite as square root of 9 times square root of 5. 9 times 5 is 45. And we know that square root of 9 is 3. Square root of 5 is irreducible, leave it the way it is. And square root of negative 1 is I. That means square root of negative 45 is 3 radical 5, 3 square root of 5 times I. So S equal to plus or minus 3 square root of 5 times I. That means there are two solutions. S could be either positive 3 square root of 5 times I, or S could be negative 3 square root of 5 times I. Next example. X plus 3 squared equal to 0. How can we solve this equation? X plus 3 squared equal to 0. When we have a perfect square on the left side, take square root on both sides. When we take square root, always add plus or minus sign. But for 0 is a special case. Positive, negative 0 is always the same as 0. Square root of 0 is 0. And positive or negative 0, they both equal to 0. Positive 0 or negative 0, they both equal to 0. So that's a special case. Only for 0, we don't add plus minus sign, because they are the same. Positive 0 and negative 0, they are the same. So 0 is a special case. When we take square root, don't add plus minus sign. Next, I can subtract 3 from both sides. If I subtract 3 from both sides, I get S equal to negative 3. That's the solution to this equation. There's only one solution. That's the solution to this equation. Next example. S minus 2 squared equal to 0. How can we solve this equation for x? When we see a perfect square on the left side, we can take square root on both sides. So we get S minus 2 equal to positive negative square root of 0. When we take square root, always add plus or minus sign. But 0 is a special case. 0 is a special case. Square root of 0 is 0. And positive 0 and negative 0, they both equal to 0. Since they are the same, we only write 0. That's a special case. Square root of 0 is 0. Positive 0 and negative 0, they are exactly the same. So square root of 0 is 0. Next, I can add 2 to both sides. If I add 2 to both sides, I get S equal to 2. That's the solution to this equation. Next example. S plus 1 squared equal to 9. How can we solve this equation for x? When we have a perfect square on the left side, I can take square root on both sides. If I take square root on both sides, I get S plus 1 equal to plus or minus square root of 9. When we take square root, always add plus or minus sign. And then we know that square root of 9 is 3. So S plus 1 equal to plus or minus 3, which means S plus 1 equal to positive 3, or S plus 1 equal to minus 3. Solve each equation for x. For the first equation, I can subtract 1 from both sides. If I subtract 1 from both sides, S equal to 2. Second equation, I can also subtract 1 from both sides. If I subtract 1 from both sides, negative 3 minus 1 is negative 4. So we get 2 solutions for this equation. We get 2 solutions to this equation. Next example. S minus 4 squared equal to 25. For this equation here, we can see that we have a perfect square on the left side. So I can take square root on both sides. If I take square root on both sides, I get S minus 4 equal to plus or minus square root of 25. Every time when we take square root, we must always add plus or minus sign. And then we know that square root of 25 is 5, which means S minus 4 either equal to positive 5 or S minus 4 equal to negative 5. Plus minus 5 means either positive 5 or negative 5. Then solve each equation for x. For the first equation, I can add 4 to both sides. If I add 4 to both sides, 5 plus 4 is 9. For the second equation, I can also add 4 to both sides. If I add 4 to both sides, negative 5 plus 4 is negative 4. So you get two solutions to this equation. You get two solutions to this equation. Next, x minus 3 squared equal to 7. X minus 3 squared equal to 7. How can we solve this equation? Same thing. When we see a perfect square on the left side, take square root on both sides. We get s minus 3 equal to plus or minus square root of 7. Square root of 7 cannot be simplified, so we leave it the way it is. That means x minus 3 equal to square root of 7, or x minus 3 equal to negative square root of 7. So x minus 3 equal to plus or minus square root of 7 means x minus 3 is either positive square root of 7 or negative square root of 7. Then solve each equation for x, which means get s by itself. So I can add 3 to both sides. If I move 3 over, negative 3 become positive 3. I get 3 plus square root of 7. If I add 3 to both sides, 3 plus square root of 7 is 3 plus square root of 7. Do the same thing to the second equation. Add 3 to both sides. If I add 3 to both sides, negative square root of 7 plus 3 is 3 minus square root of 7. Or we can also think of that. If I move negative 3 from left side to the right side, negative 3 become positive 3. If I move negative 3 from left side to the right side, negative 3 become positive 3. And square root of 7, I leave it the way it is. That's an answer. That's a solution to this equation. That's a solution to this equation. Next example. S plus 2 squared equal to 12. S plus 2 squared equal to 12. When we see a perfect square on the left side, I can take square root on both sides. When I take square root, I add plus or minus sign. When we take square root, always add plus or minus sign. Then simplify square root of 12. Square root of 12 can be rewritten as square root of 4 times square root of 3. And we know that square root of 4 is 2. Square root of 3 cannot be reduced. I leave it the way it is. So s plus 2 equal to plus or minus 2 square root of 3. Which means s plus 2 equal to 2 square root of 3, or s plus 2 equal to negative 2 square root of 3. Then in both equations, just look at s by itself. If I move positive x from left side to right side, positive x become negative x. Positive 2 become negative 2. If I move positive 2 from left side to right side, positive 2 become negative 2. And 2 square root of 3 stays the same. So x is negative 2 plus 2 square root of 3. In the second equation, if I move 2 from left side to right side, positive 2 become negative 2. And negative 2 square root of 3 stays the same. Those are the two solutions to this equation. Those are the two solutions to this equation. Next, x minus 2 squared equal to negative 16. X minus 2 squared equal to negative 16. How can we solve this equation? So when we see a perfect square on the left side, take square root on both sides. I get s minus 2 equal to plus or minus square root of negative 16. Every time when we take square root, always add plus or minus sign in the front. Next, simplify square root of negative 16. Square root of negative 16 can be rewritten as square root of 16 times square root of negative 1. And we know that square root of 16 is 4. Square root of negative 1 is I. So square root of negative 16 is 4i. Square root of negative 16 is 4i. That means s minus 2 equal to plus or minus 4i. Which means s minus 2 equal to 4i, or s minus 2 equal to negative 4i. Then in both equations, try to get s by itself. I can first of all move negative x from left side to the right side. If I move negative 2 from left side to right side, negative 2 becomes positive 2. So I get 2 plus 4i. In the second equation, if I move negative 2 from left side to right side, same thing. Negative 2 becomes positive 2. So s equal to 2 minus 4i. So there are two solutions to this equation. Next example. X minus 5 squared equal to negative 9. So when we see a perfect square root on the left side, take square root on both sides. We get x plus 5 equal to plus or minus square root of negative 9. Then simplify square root of negative 9. Square root of negative 9 can be written as square root of 9 times square root of negative 1. And we know that square root of 9 is 3. Square root of negative 1 is I. So square root of negative 9 is 3i. That means s plus 5 equal to plus or minus 3i. Which means s plus 5 equal to 3i, or s plus 5 equal to negative 3i. Next, to look at s by itself. In order to look at s by itself, I need to move positive 5 from left side to right side. When I move positive 5 from left side to right side, positive 5 becomes negative 5. So I get negative 5 plus 3i. In the second equation, if I move positive 5 from left side to right side, positive 5 becomes negative 5. And negative 3i stays the same. And the solution is s equal to negative 5 plus 3i, or s equal to negative 5 minus 3i. Those are the two solutions to this equation. Next example. X minus 6 squared equal to negative 10. How can we solve this equation for x? When we have a perfect square root on the left side, I can take square root on both sides. If I take square root on both sides, I get s minus 6 equal to plus or minus square root of negative 10. Every time when we take square root, always add plus or minus sign. Now, next, what's square root of negative 10? Square root of negative 10 can be rewritten as square root of 10 times square root of negative 1. Square root of 10 cannot be reduced, so I leave it the way it is. Square root of negative 1 is I. So square root of negative 10 is square root of 10 times I. So s minus 6 is plus or minus square root of 10 I. Then that means x minus 6 equal to 10 square root of 10 I, or s minus 6 equal to square root of negative square root of 10 I. Negative square root of 10 I. Next, in both equations, try to look at s by itself. So in the first equation, I can try to move negative 6 from left side to right side. If I move 6 over, negative 6 becomes positive 6. So I get 6 plus square root of 10 I. In the second equation, if I move negative 6 from left side to right side, negative 6 becomes positive 6. And the right side stays the same. Negative square root of 10 I. Those are the two solutions to this equation. Next example. S plus 4 squared equal to negative 18. How can we solve this equation? When we see a perfect square root on the left side, I can take square root on both sides. I get x plus 4 equal to plus or minus square root of negative 18. Every time when we take square root, always add plus or minus sign in the front. Now, what's square root of negative 18? Square root of negative 18 can be rewritten as square root of 18 times square root of negative 1. And square root of 18 can be written as square root of 9 times square root of 2. 9 times 2 is 18. And we know that square root of 9 is 3. Square root of 2 cannot be reduced, and leave it the way it is. Square root of negative 1 is I. So square root of negative 18 is 3 square root of 2i. That means s plus 4 equal to plus or minus 3 square root of 2i. That means s plus 4 is either 3 square root of 2i, or s plus 4 equal to negative 3 square root of 2i. Then on each equation, try to look at s by itself. In the first equation, If I move positive 4 from left side to right side, positive 4 become negative 4. So s equal to negative 4 plus 3 square root of 2i. In the second equation, if I move 4 from left side to right side, it becomes s equal to negative 4 minus 3 square root of 2i. Those are the two solutions to this equation. Those are the two solutions to this equation. Next example, x squared minus 6x plus 4 equal to 0. How can we solve this equation for x? We know that the left side of the equation is a trinomial, which is factorable. If we solve this equation by factoring, we get two solutions, s equal to 1 and s equal to 5. Or if we try to solve this equation by completing square, what do we get? In order to solve this equation by completing square, first step, keep x on the left side. Keep x squared minus 6x on the left side. Move the single number to the right side. If I move number 5 from left to right, positive 5 become negative 5. When we move number 5 over, the sign changed. Positive 5 become negative 5. Next, we try to complete squares. Match the form. A squared plus 2ab plus b squared. That equal to a plus b squared. Or try to match the form. A squared minus 2ab plus b squared equal to a minus b squared. They are called perfect square trinomials. We try to complete square, make the left side match these two perfect square trinomials. So here, we try to add a term here to make it match the perfect square trinomial. What we can do here is take the middle number, divide by 2. Take the middle number, take negative 6, divide by 2. I get negative 3. Next, square this number. Negative 3 squared is 9. Negative 3 squared is 9. Add 9 to the left side and right side. Add 9 to the left side and right side. Now we have x squared minus 6x plus 9. It match this perfect square trinomial here. There, x squared represents a squared. B squared represents 9. 9 is 3 squared. In the middle, we have 2 times x times 3. 2 times x times 3 is negative 6x. So we have x squared minus 6x plus 9. Imagine this perfect square trinomial, where a is x, b is 3. So we get a minus b squared, which is x minus 3 squared. So the left side match the perfect square trinomial. That's x minus 3 squared. On the right side, negative 5 plus 9 is 4. So in general, if we take the middle number, divide by 2, and then square the number added to both sides, the left side will match the perfect square, x minus 3 squared. Left side always match the trinomial, x minus 3 squared. If we take the middle number, divide by 2, and then square the number added to both sides, the left side always match the perfect square trinomial, x minus 3 squared. Then solve for x from here. Here, left side is a perfect square. If I take square root on both sides, x minus 3 equal to plus or minus square root of 4. And we know that square root of 4 is 2. X minus 3 equal to plus or minus 2. That means x minus 3 is either positive 2 or x minus 3 equal to negative 2. Solve both equations for x. In the first equation, I can add 3 to both sides. 2 plus 3 is 5. In the second equation, I can also add 3 to both sides. Negative 2 plus 3 is positive 1. So we get two solutions. S equal to positive 5, S equal to positive 1, which is exactly the same solution as we have here. So solve equation by factoring or by completing square, we get exactly the same solution. So we get exactly the same solution if we solve the same equation by completing squares. Next example. S squared plus 4x minus 12. This equation is factorable. If we solve this equation by factoring, we get two solutions. S equal to 2 and S equal to 6 equal to negative 6. Let's try to solve the same equation by completing square. So if we try to solve this equation by completing square, first step, keep x on the left side. Move the single number to the right side. If I move negative 12 over, negative 12 becomes positive 12. Then, next, try to complete square on the left side. So in order to complete square, we try to add a term here to match this equation, to match the left side with a perfect square trinomial. So take the middle term, which is positive 4. Divide by 2, I get positive 2. Take the middle term, take the middle number, divide by 2, I get positive 2. Then square this number. Positive 2 squared is 4. Add 4 to the left side and right side. I get s squared plus 4x plus 4 equal to 12 plus 4. Add 4 to the left side and right side. If I add 4 to the left side and right side, we can see that here, the left side match the perfect square trinomial here. S squared plus 2ab plus b squared. So s squared match a squared. B squared match 4. 4 is 2 squared. And then for 2ab, I can write it as 2 times x times 2. 2 times x times 2. 2 times x times 2 is 4x. Then match the middle term here. So since this is a trinomial, since this is a perfect square trinomial, it can be noted as a plus b squared, which is x plus 2 squared. If we divide the middle number by 2 and then square the number, add it to both sides, it must be the trinomial x plus 2 squared. It must be the trinomial x plus 2 squared. That's the left side. On the right side, 12 plus 4 is 16. Then on the left side is a perfect square. I can take square root on both sides. If I take square root on both sides, s plus 2 equal to plus or minus square root of 16. And then we know that square root of 16 is 4. That means s plus 2 equal to 4, or s plus 2 equal to negative 4. Solve both equations for x. If I solve the first equation for x, I can subtract 2 from both sides. 4 minus 2 is 2. In the second equation, I can also subtract 2 from both sides. If I subtract 2 from both sides, s equal to negative 4 minus 2 is negative 6. So we get two solutions. S equal to 2 and s equal to negative 6. So if we solve an equation by completing square, we get exactly the same answer as we solve it by factoring. Next example, x squared minus 10x plus 9 equal to 0. How can we solve this equation by completing square? So first step, we keep x on the left side. Move the single number to the right side. If I move 9 to the right side, positive 9 becomes negative 9. Next, try to complete square on the left side. So on the left side, take the middle number, negative 10, divide by 2, I get negative 5. And then take a negative 5 square, that's 25. Add 25 to both sides. Add 25 to the left side and right side. If I add 25 to the left side, then left side match the perfect square trinomial a squared minus 2ab plus b squared. So since it matches perfect square trinomial, I can use this number to make perfect square. Write it as x minus 5 squared. That's how we factor the left side. On the right side, negative 9 plus 25. is positive 16. Negative 9 plus 24 is positive 16. Then, since left side is a perfect square, I can take square root on both sides. If I take square root, I get s plus s minus 5. Equal to plus or minus square root of 16. When we take square root, always add plus minus sign. And we know that square root of 16 is 4. So x minus 5 equal to plus or minus 4, which means s minus 5 equal to 4 or s minus 5 equal to negative 4. Then solve each equation individually. For the first equation, I can add 5 to both sides. I can s equal to 9. For the second equation, I can also add 5 to both sides. Negative 4 plus 5 is positive 1. So there are two solutions, s equal to 9 and s equal to 1. Next example, s squared plus 12x plus 20. Solve this equation by completing square. So first step, we keep x on the left side. Keep x squared plus 12x on the left side. And move positive 20 from left side to the right side. If I move 20 over, positive 20 becomes negative 20. Next, we try to complete square on the left side. On the left side, the middle coefficient here is 12. Take 12, take positive 12 divided by 2, I get positive 6. Then square this number. Take positive 6 squared, I get 36. Add 36 to both sides, to the left side and right side. If I add 36 to the left side, it completes the square. Imagine the perfect square trinomial, a squared plus 2ab plus b squared. Imagine a perfect square trinomial. Then I can use this number, positive 6, to make perfect square. Write it as s plus 6 squared. That's on the left side. On the right side, negative 20 plus 36 is positive 16. When the left side is a perfect square, I can take square root on both sides. If I take square root on both sides, I get s plus 6 equal to positive or negative square root of 16. So whenever I take a square root, always add plus or minus sign. Next, that means s plus 6 equal to positive negative 4. Square root of 16 is 4. So s plus 6 is either positive 4 or negative 4. Solve each equation individually. For the first equation, I can subtract 6 from both sides. If I subtract 6 from both sides, 4 minus 6 is negative 2. For the second equation, I can also subtract 6 from both sides. If I subtract 6 from both sides, negative 4 minus 6 is negative 10. So you got two solutions, s equal to negative 2 and s equal to negative 10. Next example, s squared plus ax plus 11 equal to 0. S squared plus ax plus 11 equal to 0. For this equation, you can see that it's not factorable. We have no choice. We have to solve it using completing square. This equation is not factorable. We don't have other choice. So the only choice for us is solve the equation by completing square. So first step, keep x on the left side. Move the single number to the right side. If I move positive 11 over, positive 11 becomes negative 11. Next, try to complete square on the left side. On the left side, the middle term is positive a. Take positive a divided by 2, I get positive 4. Then take positive 4 squared, I get 16. Add 16 to both sides. Add 16 to the left side and right side. I get x plus ax, s squared plus ax plus 16 equal to negative 11 plus 16. Then on the left side, imagine the perfect square trinomial, a squared plus 2ab plus b squared. We can use this number to complete the squares, to make perfect square. Write it as x plus 4 squared equal to negative 11 plus 16 is positive 5. Next, once we have a perfect square on the left side, I can take square root on both sides. If I take square root, I get s plus 4 equal to plus or minus square root of 5. Every time when we take square root, always add plus or minus sign. Then try to look at s by itself. S plus 4 equal to plus or minus square root of 5. That means s plus 4 equal to square root of 5, or s plus 4 equal to negative square root of 5. We try to look at s by itself in both equations. So I can move 4 over. If I move number 4 from left side to right side, number 4 becomes negative 4. In the second equation, if I move 4 from left side to right side, positive 4 becomes negative 4. I get negative 4 minus square root of 5. So there are two solutions to this equation. Next example. S squared minus 10x plus 19 equal to 0. S squared minus 10x plus 19 equal to 0. We can see that this equation is not factorable. So the only choice for us is solve by completing squares. So in order to complete squares, keep x on the left side. Move from the single number 19 to the right side. 19 is positive. If I move over, positive 19 becomes negative 19. Next, try to complete square using the middle number here. The middle number is negative 10. So I take negative 10 divided by 2, which is negative 5. Then square this number. Negative 5 squared is positive 25. Add 25 to the left side and right side. I get s squared minus 10x plus 25 equal to negative 19 plus 25. Then here, left side is a perfect square trinomial. We can use negative 5 to make perfect square. Write it as s minus 5 squared. That's the left side. On the right side, negative 19 plus 25 is 6. When we have a perfect square on the left side, I can take square root on both sides. I get s minus 5 equal to plus or minus square root of 6. Which means s minus 5 is either positive square root of 6 or negative square root of 6. On each equation, try to look at s by itself. In the first equation, I can add 5 to both sides, or move 5 from left side to the right side. I get s equal to 5 plus square root of 6. This is negative 5. If I move over, negative 5 becomes positive 5. For the second equation, do the same thing. Move negative 5 from left side to the right side. This is negative 5. If I move over, it becomes positive 5. So you got two solutions. 5 plus square root of 6 and 5 minus square root of 6. Next example. S squared plus 6x minus 3 equals 0. Here we can see that the left side of the equation is not factorable. When it's not factorable, we can try to solve an equation by completing squares. So first step, we keep x on the left side. Then move from the single number to the right side. When I move negative 3 over, it becomes positive 3. Next, we try to complete square on the left side. So first of all, I take positive 6. Take the middle number, positive 6. Divide by 2, I get positive 3. Then square this number. Positive 3 squared is 9. Positive 3 squared is 9. Add 9 to both sides. I get s squared plus 6x plus 9 equal to 3 plus 9. Add 9 to both sides. Next, the left side here match a perfect square trinomial. We can use this number to write it as a perfect square. So left side can be written as x plus 3 squared. That's the left side. On the right side, 3 plus 9 is 12. Then, once we have perfect square on the left side, I can take square root on both sides. So I get s plus 3 equal to plus or minus square root of 12. When we take square root, always add plus minus sign. Next, simplify square root of 12. Square root of 12 can be written as square root of 4 times square root of 3. And we know that square root of 4 is 2. Square root of 3 cannot be reduced, so I leave it the way it is. So we get s plus 3 equal to plus or minus 2 square root of 3. Which means x plus 3 is either 2 square root of 3 or negative 2 square root of 3. Then solve each equation for x. In the first equation, if I move positive 3 from left side to right side, positive 3 becomes negative 3. So I get negative 3 plus 2 square root of 3. In the second equation, if I move 3 from left side to right side, positive 3 become negative 3. So I get s equal to negative 3 minus 2 square root of 3. So we have two solutions to this equation. Next example, s squared minus 4x minus 16 equal to 0. We can see that here, the left side of the equation is not factorable. When it's not factorable, we try to solve the equation by completing squares. So first of all, I keep x on the left side. Move negative 16 from left side to right side. If I move 16 over, negative 16 become positive 16. Next, try to add a term here on the left side and right side to make a perfect square. What we can do is take the middle number, negative 4, divide by 2, I get negative 2. Then square this number. Negative 2 squared is positive 4. Add 4 to the left side and right side of the equation. So I get s squared minus 4x plus 4 equal to 16 plus 4. Add 4 to both sides. Next, here, left side match in a perfect square trinomial. We can use this number here to write it as a perfect square. So left side can be written as x minus 2 squared. That's the left side. On the right side, 16 plus 4 is 20. Once I get perfect square on the left side, I can take square root of both sides. So I get s minus 2 equal to plus or minus square root of 20. Every time when I take square root, always add plus minus sign. When we take square root, always add plus or minus sign. Next, simplify square root of 20. Square root of 20 can be rewritten as square root of 4 times square root of 5. And we know that square root of 4 is 2. Square root of 5 cannot be reduced, so leave it the way it is. Square root of 5 cannot be reduced, leave it the way it is. So we get s minus 2 equal to plus or minus 2 square root of 5. Which means s minus 2 equal to 2 square root of 5, or s minus 2 equal to negative 2 square root of 5. On each equation, try to get s by itself. In the first equation, I can move negative 2 from left side to right side. If I move negative 2 over, negative 2 become positive 2. So I get 2 plus 2 square root of 5. In the second equation, same thing. If I move negative 2 over, negative 2 become positive 2. So I get 2 minus 2 square root of 5. Those are the solutions to this equation. Those are the solutions to this equation. Next example. S squared minus 12x plus 41 equal to 0. S squared minus 12x plus 41 equal to 0. We can see that here, this equation is not factorable. The left side is not factorable. When it's not factorable, try to solve the equation by completing squares. So I leave x on the left side and move the single number to the right side. If I move positive 41 over, positive 41 become negative 41. Next, try to make a perfect square on the left side. So on the left side, take the middle number, take negative 12, divide by 2, I get negative 6. Then square this number. Negative 6 squared is 36. So add 36 to the left side and right side. We get s squared minus 12x plus 36 equal to negative 41 plus 36. Left side is a perfect square trinomial. We can use this number to write it as a perfect square. So I write it as x minus 6 squared. That's the left side. On the right side, negative 41 plus 36 is negative 5. Once we get perfect square on the left side, we can take a square root on both sides. So we get s minus 6 equal to plus or minus square root of negative 5. Every time when we take square root, always add plus or minus sign. Next, simplify square root of negative 5. Square root of negative 5 can be written as square root of 5 times square root of negative 1. And we know that square root of 5 cannot be reduced. We leave it the way it is. Square root of negative 1 is I. So the answer is square root of 5 times I. So square root of negative 5 equal to square root of 5 times I. So we get s minus 6 equal to plus or minus square root of 5 times I. Which means x minus 6 is either square root of 5i or negative square root of 5i. Next, for both equations, try to get s by itself. In the first equation, if I move negative 6 over, negative 6 becomes positive 6. S equal to 6 plus square root of 5i. In the second equation, if I move negative 6 over, negative 6 becomes positive 6. I get s equal to 6 minus square root of 5i. So I get two solutions to this equation. Next example. S squared minus 2x plus 7 equal to 0. We can see that the left side of an equation is not factorable. When it's not factorable, we can try to solve an equation by completing squares. So first of all, we leave x on the left side. Move the single number to the right side. When I move positive 7 over, positive 7 becomes negative 7. Next, try to complete square on the left side. So on the left side, first of all, take the middle number. Take negative 2, divide by 2, get negative 1. Then square this number. Negative 1 squared is positive 1. So we can add 1 to both sides. Add 1 to both sides to make perfect squares. I get s squared minus 2x plus 1 equal to negative 7 plus 1. Add 1 to both sides to make perfect squares. So on the left side, that's a perfect square trinomial. We can use this number to write it as a perfect square. I write left side as x minus 1 squared equal to negative 7 plus 1 is negative 6. Once we get perfect square on the left side, I can take square root on both sides. If I take square root, I get s minus 1 by itself on the left side. On the right side, I get plus or minus square root of negative 6. Square root of negative 6 can be rewritten as square root of 6 times square root of negative 1. We know that square root of 6 cannot be reduced, so I leave it the way it is. Square root of negative 1 is I. So square root of negative 6 is square root of 6i. So s minus 1 equal to plus or minus square root of 6i. That means s minus 1 equal to 6 square root of 6i or negative square root of 6i. Next, on each equation, try to get s by itself. So here on the first equation, I can add 1 to both sides, which means move 1 over. If I move negative 1 from left side to right side, negative 1 becomes positive 1. So I get 1 plus square root of 6i. In the second equation, do the same thing. Move negative 1 from left side to the right side. If I move negative 1 from left side to the right side, negative 1 becomes positive 1. I get 1 minus square root of 6 times I. That's the solutions. Those are the solutions to the equation. Next example. S squared minus ax plus 24 equal to 0. How can we solve this equation? Here we can see that the left side of an equation is not factorable. When it's not factorable, try to solve an equation by completing squares. So first of all, leave x on the left side. Next, move 24 from the left side to the right side. If I move 24 over, positive 24 becomes negative 24. Next, try to complete square on the left side. On the left side, take the middle number, take negative a divided by 2. We get negative 4. Then square this number. Negative 4 squared is 16. Add 16 to the left side and right side. We get s squared minus ax plus 16 equal to negative 24 plus 16. Once I add 16 to the left side, it becomes a perfect square trinomial. Then we can use this number to write it as a perfect square. Here, left side can be written as x minus 4 squared. On the right side, negative 24 plus 16 is negative a. Once we get perfect square on the left side, we can take square root on both sides. We get s minus 4 equal to plus or minus square root of negative a. And square root of negative a can be simplified as square root of a times square root of negative 1. And we know that square root of a can be written as square root of 4 times square root of 2. Square root of 4 is 2. Square root of 2 cannot be reduced, so leave it the way it is. square root of negative 1 is I. So square root of negative a can be written as 2 square root of 2i. So s minus 4 equal to plus or minus 2 square root of 2i, which means s minus 4 equal to 2 square root of 2i, or s minus 4 equal to negative 2 square root of 2i. In both equations, try to get s by itself. In the first equation, I can move negative 4 from left side to right side. If I move negative 4 over, negative 4 becomes positive 4. In the second equation, do the same thing. Move negative 4 from left side to right side. We get s equal to 4 minus 2 square root of 2i. If I move negative 4 over, negative 4 becomes positive 4. So you get 4 minus 2 square root of 2i. Those are the solutions to the equation. Next example. S squared minus 6x plus 33 equal to 0. Here we can see that the left side of the equation is not factorable. When it's not factorable, we can try to solve the equation by completing squares. So I first of all keep x on the left side. Move the single number to the right side. If I move positive 33 over, positive 33 becomes negative 33. Next, try to complete square on the left side. On the left side, the middle number is negative 6. Take the negative 6 divided by 2, we get negative 3. Then square this number. Negative 3 squared is positive 9. Next, I can add 9 to both sides. If I add 9 to both sides, I get s squared minus 6x plus 9 equal to negative 33 plus 9. Here, left side is a perfect square trinomial. We can use this number to write it as a perfect square. So left side can be written as x minus 3 squared. On the right side, negative 33 plus 9 is negative 24. Once we have a perfect square on the left side, we can take square root on both sides. We get s minus 3 equal to plus or minus square root of negative 24. And we know that square root of negative 24 can be reduced. It can be written as square root of 24 times square root of negative 1. Square root of 24 can be written as square root of 4 times square root of 6. And we know that square root of 4 is 2. Square root of 6 is irreducible, even though it is. Square root of negative 1 is I. So the right side here can be rewritten as plus or minus 2 square root of 6i, which means x minus 3 equal to 2 square root of 6i, or x minus 3 equal to negative 2 square root of 6i. In both equations, try to get s by itself. In both equations, try to get s by itself. In the first equation, I can move negative 3 from left side to right side. If I move negative 3 from left side to right side, negative 3 becomes positive 3. So s equal to 3 plus 2 square root of 6i. In the second equation, do the same thing. We can move negative 3 from left side to right side. If I move it over, it becomes 3 minus 2 square root of 6i. So those are the two solutions to the equation. Another technique of solving equation is by quadratic formula. For any equation in the form of ax squared plus bx plus c equal to 0, the solution is s equal to negative b plus or minus square root of b squared minus 4ac all over 2a. That's the solution to this equation in the form of ax squared plus bx plus c equal to 0. Next, let's look at an example here. For this example, x squared minus 6x plus 5 equal to 0. We know that if we solve this equation by factoring, the solution is s equal to 1 and s equal to 5. If we solve this equation by quadratic formula, then the coefficient of x squared is 1. So a is 1. Coefficient of x is negative 6. So b is negative 6. And a single number by itself is 5. C is 5. These three numbers, they are a, b, c. Then use quadratic formula. S equal to negative b. Here b is negative 6. So we write negative 6. B is negative 6. So we write negative 6. plus or minus square root of b squared, b is negative 6. We write negative 6 squared minus 4 times a is 1, times c is 5, all over 2a is 1. Then simplify. Negative 6, double negative is positive, we get positive 6. Plus or minus stays the same. Under square root, negative 6 squared is 36. 4 times 1 times 4 is 20. On the denominator, 2 times 1 is 2. Then simplify. I get 6 plus or minus 36 minus 20 is 16. I get square root of 16. Then square root of 16 is 4. That means s equal to either 6 plus 4 over 2 or s equal to 6 minus 4 over 2. Plus minus means either s is 6 plus 4 over 2 or s could be 6 minus 4 over 2. Then if we use for the first part here, if I add the numerator first, 6 plus 4 is 10. 10 divided by 2 is 5. For the second equation here, 6 minus 4 is 2. 2 over 2 is 1. We get two solutions, s equal to 5, s equal to 1. That's the same as we have here. S equal to 1, s equal to 5. If we solve the equation by factoring, we get exactly the same answer. So another technique of solving equation is called solving by quadratic formula. Solving by quadratic formula. This formula is called quadratic formula. S equal to negative b plus or minus square root of b squared minus 4ac all over 2a. Another example, s squared plus 4x minus 12 equal to 0. If we use quadratic formula, we need to recognize what's a, b, c first. Here a is 1, b is 4, c is negative 12. Then plug in. S equal to negative b plus or minus square root of b squared minus 4 times a times c. B squared minus 4ac over 2a. A is 1. Then plug in. We have negative 4 plus or minus square root of 4 squared is 16. 4 times 1 is 4. 4 times 12 is 48. Double negative is positive. We get positive 48. On the bottom, 2 times 1 is 2. Simplify, we get negative 4 plus or minus 16 plus 48 is 64. Keep the bottom the same. Then on the numerator, square root of 64 is a. We get plus or minus a over 2. Which means s equal to negative 4 plus a over 2, or s equal to negative 4 minus a over 2. Then solve each of them individually. For the first part, negative 4 plus a is positive 4. 4 over 2 is 2. For the second part here, negative 4 minus a is negative 12. Negative 12 divided by 2 is negative 6. We get two solutions, s equal to 2 and s equal to negative 6. That's exactly the same as we solve the equation by factoring. If we solve this equation by factoring, we get exactly the same solution. So that's another technique of solving equations, called solving by quadratic formula. Next example, 2x squared plus 7x plus 6 equal to 0. How can we solve this equation by quadratic formula? First step, try to recognize a, b, and c. Here a is 2, b is 7, c is 6. Plug in. S equal to negative b plus or minus square root of b squared minus 4ac all over 2a. Here a is 2. Then simplify. I get negative 7 plus or minus 7 squared is 49 minus 4 times 2 is 8. 8 times 6 is 48. On the denominator, 2 times 2 is 4. Next, we have negative 7 plus or minus square root of 49 minus 48 is 1. And we know that square root of 1 is 1. Then we have two solutions. S equal to negative 7 plus 1 over 4, or S equal to negative 7 minus 1 over 4. If we simplify the first solution here, negative 7 plus 1 is negative 6. Negative 6 divided by 4, it can be simplified as negative 3 over 2. That's one solution. Another solution here, negative 7 minus 1 is negative 8. Negative 8 over 4 is negative 2. So we get two solutions to this equation. We can also solve this equation by factoring. Next example, 4x squared minus ax minus 5. If we solve this equation by quadratic formula, first step, try to recognize a, b, and c. Here a is 4, b is negative a, c is negative 5. Plug a, b, c into the formula. S is negative b plus or minus square root of b squared minus 4ac. 4 times a times c, all over 2a. A is 4. Then simplify. Negative a, double negative is positive. Plus or minus. Under square root here, negative a squared is 64. 4 times 4 is 16. 16 times 5. 16 times 5 is 80. Double negative is positive. 2 times 4 is 8. Then simplify. Under square root, 64 plus 80 is 144. Square root of 144 is 12. So we get two solutions. S equal to a plus 12 over a, or S equal to a minus 12 over a. For the first solution here, a plus 12 is 20. I get 20 over a. 20 over a can be reduced as 5 over 2. I can divide top and bottom by 4. I get 5 over 2. That's one solution. Another solution here, a minus 12 is negative 4. Negative 4 over a. Here, negative number divided by positive number is negative. 4 over a can be reduced as 1 over 2. So those are the solutions to this equation. If we solve this equation by factoring, we should get the same answer. Next example, x squared plus ax plus 11 equal to 0. If we try to solve this equation by quadratic formula, first step, try to organize a, b, and c. Here a is 1, b is a, c is 11. Then plugging a, b, c into the quadratic formula. S equal to negative b plus or minus square root of b squared minus 4 times a times c. Negative b squared plus or minus negative b plus or minus square root of b squared minus 4ac all over 2a. Here a is 1. Then simplify. I get negative a plus or minus square root of a squared is 64. 4 times 1 is 4. 4 times 11 is 44. On the bottom, 2 times 1 is 2. Then simplify. 64 minus 44 is 20. So I get square root of 20 all over 2. Now next, simplify square root of 20. Square root of 20 can be written as square root of 4 times square root of 5. And we know that square root of 4 is 2. Square root of 5 cannot be reduced, leave it the way it is. We get s equal to negative a plus or minus 2 square root of 5 over 2. That means there are two solutions. S could be negative a plus 2 square root of 5 over 2, or s could be negative a minus 2 square root of 5 over 2. For the first equation, I can divide both top and bottom by 2. A divided by 2 is 4. 2 divided by 2 can cancel, get square root of 5. For the other solution, negative a divided by 2 is negative 4. And negative 2 divided by 2, 2 can cancel, I get negative square root of 5. So those are two solutions to this equation. For this equation, we can also solve it by completing squares. We should get exactly the same answer if we solve this equation by completing squares. Next example, x squared minus 10x plus 19 equal to 0. If we try to solve this equation by quadratic formula, first step, try to recognize a, b, and c. Here a is 1, b is negative 10, c is 19. Then plug in a, b, and c, find x. S equal to negative b, here b is negative 10, so we get negative 10 plus or minus square root of b squared minus 4 times a times c all over 2a. Then simplify. Negative 10, double negative is positive, okay, positive 10 plus or minus under square root we have negative 10 squared. Negative 10 squared is positive 100 minus 4 times 1 is 4, and then 4 times 19 is 76. On the bottom, 2 times 1 is 2. Then simplify the square root. 100 minus 76 is 24. So we get 24 under the square root. What's square root of 24? Square root of 24 can be written as square root of 4 times square root of 6. Square root of 4 is 2. Square root of 6 cannot be reduced, so I leave it the way it is. So s equal to 10 plus or minus 2 square root of 6 over 2. That means s equal to 10 plus 2 square root of 6 over 2, or s equal to 10 minus 2 square root of 6 over 2. If we simplify, take both number on the top divided by number on the bottom. 10 divided by 2 is 5. 2 divided by 2 can cancel, you get square root of 6. For the other solution, 10 divided by 2 is 5. 2 divided by 2 can cancel, we get negative square root of 6. So we get two solutions to this equation. Next example. S squared minus 12x plus 41 equal to 0. S squared minus 12x plus 41 equal to 0. If we try to solve this equation by quadratic formula, first step, try to recognize a, b, and c. Here a is 1, b is negative 12, and c is 41. Then plug a, b, c into this formula. This formula is called quadratic formula. So plug in a, b, c. S equal to negative b plus or minus square root of b squared minus 4ac. Negative b plus or minus square root of b squared minus 4ac all over 2a. Then simplify here. Double negative is positive. Negative 12 is positive 12. Plus or minus negative 12 squared is 144. 4 times 1 is 4. And 4 times 41 is 164. On the bottom, 2 times 1 is 2. Next, simplify the square root. Under square root, 144 minus 164 is negative 20. Next, let's simplify. Square root of negative 20. Square root of negative 20 can be written as square root of 20 times square root of negative 1. Square root of 20 can be written as square root of 4 times square root of 5. And we know that square root of 4 is 2. Square root of 5 is irreducible, we leave it the way it is. And square root of negative 1 is I. So square root of negative 20 is 2 square root of 5 I. So you get 12 plus or minus 2 square root of 5 I over 2. That means we have two solutions. S equal to 12 plus 2 square root of 5 I over 2. Or S equal to 12 minus 2 square root of 5 I over 2. Simplify each of them individually. For the first one, 12 divided by 2 is 6. For the second term here, 2 divided by 2 can cancel, so we get square root of 5i. For the other solution, 12 divided by 2 is 6. 2 divided by 2 can cancel, we get negative square root of 5i. So we get two solutions to this equation. Next example, x squared minus 2x plus 7 equal to 0. How can we solve this equation by quadratic formula? First step, try to recognize a, b, and c. Here a is 1, b is negative 2, c is 7. Plugging a, b, c into the quadratic formula. So s equal to negative b plus or minus square root of b squared minus 4ac all over 2a. Then simplify. Negative 2, double negative is positive. Plus or minus square root of negative 2 squared is 4. 4 times 1 is 4, and times 7 is 28. All over 2 times 1 is 2. Under square root, 4 minus 28 is negative 24. Next, let's simplify. Square root of negative 24. Square root of negative 24 can be written as square root of 24 times square root of negative 1. And we know that square root of 24 can be written as square root of 4 times square root of 6. Square root of 4 is 2. Square root of 6 is irreducible, so I leave it the way it is. Square root of negative 1 is I. So together, square root of negative 24 is 2 square root of 6i. So square root of negative 24 is 2 square root of 6i all over 2. That means x is either 2 plus 2 square root of 6i over 2, or s could be 2 minus 2 square root of 6i over 2. There are two solutions. Then simplify the first solution. 2 over 2 is 1. Second part, 2 can cancel, we get square root of 6i. That's the first solution. Second solution, 2 divided by 2 is 1. Minus 2 divided by 2 can cancel, 2 divided by 2 can cancel, we get square root of 6i. So we get two solutions to this equation. We can also solve this equation by completing squares, which get exactly the same answer. Next example, 2x squared plus 4x minus 3 equal to 0. How can we solve this equation? Can we factor this equation? Can we factor the left side? If we try to factor the left side using AC method, here AC is negative 6. AC is negative 6. Can we find two numbers that multiply to be negative 6 and add to be 4? Can we find two numbers that multiply to be negative 6 and add to be 4? It seems impossible. So this polynomial is not factorable. The left side is not factorable. We cannot solve it by factoring. Can we solve this equation by completing squares? Can we solve this equation by completing squares? If we try to solve this equation by completing square, first step, we need to divide both sides by 2. we get x squared plus 2x minus 3 over 2 equal to 0. Then keep x on the left side. Move the single number to the right side. Then solve it by completing square. It's okay, but when we have fraction, it makes the problem harder. So solving by completing square is not a good choice here. Once we have a fraction, solve it by completing square is not a good choice. So the best choice for us here is solve by quadratic formula. The best choice for us here is solve by quadratic formula. If we try to solve it using quadratic formula, we need to memorize the formula. The formula is x equal to minus b plus or minus square root of b squared minus 4ac all over 2a. Then recognize ABC. Here a is 2, b is 4, c is -3. These three numbers, they are a, b, and c. The coefficient of x squared is a. Coefficient of x is b. A single number by itself is c. Then plug ABC into this formula. S equal to -b plus or minus square root of b squared minus 4 times a times c all over 2a. Simplify, we get -4 plus or minus 4 squared is 16. Under square root, 4 times 2 is a. A times 3. A times -3 is -24. Double negative is positive. We get positive 24. On the bottom, 2 times 2 is 4. Then simplify. Under square root, 16 plus 24 is 40 over 4. Next, simplify square root of 40. Square root of 40 can be written as square root of 4 times square root of 10. And we know that square root of 4 is 2. Square root of 10 cannot be reduced. We leave it the way it is. So square root of 40 is 2 square root of 10. That means s could be -4 plus 2 square root of 10 over 4. Or s could be -4 minus 2 square root of 10 over 4. Now here we can see that if I take top divided by bottom, 2 divided by 4 is not divisible because 4 is larger. 2 divided by 4 is not divisible. Since they are not divisible, look at these three numbers, 4, 2, and 2. Do they have any common factor? Do they have any common factor? 4, 2, and 2, the common factor here is 2. So I can divide all three numbers by 2. I get -2 plus square root of 10 over 2. Here I divide all three numbers by 2. Same thing for the other solution here. 2 divided by 4 is not divisible. But I have a common factor 2. So I can divide all three numbers by 2. I get -2 minus square root of 10 over 2. So we get two solutions to this equation. Next example, 3x squared minus 5x minus 1 equal to 0. How can we solve this equation? If we try to solve this equation by factoring, we can see that it's not factorable. 3 times -1 is -3. AC is -3. Can we find two numbers that multiply to be -3 and to be -5? It seems impossible, so it's not factorable. If it's not factorable, can we solve this equation by completing square? If I divide both sides by 3, try to isolate s squared. If I divide both sides by 3, I get s cubed minus 5 over 3x minus 1/3 equal to 0. Once it contains fraction, once this equation contains fraction, it's very hard to solve the equation by completing square. So for this equation, the best choice for us is solved by quadratic formula. For quadratic formula, first step, try to recognize a, b, and c. Here a is 3, b is -5, c is -1. That's the best choice for us, solved by quadratic formula. Plugging a, b, and c into the quadratic formula. S equal to -b plus or minus square root of b squared minus 4 times a times c. C is negative 1. a3, c is negative 1. All over 2a, a3. Then simplify. Negative, negative 5. Double negative is positive. We get positive 5. Plus or minus square root of negative 5 squared is 25. 4 times 3 is 12. 12 times negative 1 is negative 12. Double negative is positive. On the bottom, 2 times 3 is 6. (25) plus 12 is 37. Square root of 37 cannot be reduced, so leave it the way it is. So that means we have two solutions: 5 plus square root of 37 over 6, or 5 minus square root of 37 over 6. There are two solutions. Since square root of 37 cannot be reduced, this solution cannot be reduced. So that's the final answer to this equation. Next example: 5x squared plus 6x plus 2 equal to 0. How can we solve this equation? This equation is not factorable. It's hard to use. It's hard to complete squares. So the best choice for us is solve by quadratic formula. For quadratic formula, first step, recognize a, b, and c. First step, recognize a, b, and c. Here a is 5, b is 6, c is 2. Once we recognize a, b, c, plugging a, b, and c into the quadratic formula. S equal to negative b plus or minus square root of b squared minus 4ac. That's a, that's c. All over 2a. Then simplify. 6 squared is 36. 4 times 5 is 20. 20 times 2 is 40. On the bottom, 2 times 5 is 10. Simplify. We get negative 6 plus or minus. Under square root, we have 36 minus 40, which is negative 4. What's square root of negative 4? Square root of negative 4 can be written as square root of 4 times square root of negative 1. And we know that square root of 4 is 2. Square root of negative 1 is I. So square root of negative 4 is 2i. Square root of negative 4 is 2i. That means there are two solutions. S could be either negative 6 plus 2i over 10, or negative 6 minus 2i over 10. In general, for complex numbers, try to write it in standard form. For complex numbers, try to put it in standard form. Standard form means put a real number by itself and put an imaginary number by itself. We have negative 6 over 10 plus 2i over 10. Negative 6 over 10, I can divide top and bottom by 2. Make it negative 3 over 5. Then for 2 over 10, I can divide top and bottom by 2. Make it 1 over 5 times I. That's the standard form of the complex number. For the other solution, do the same thing. Separate the real part and the imaginary part. We get negative 6 over 10 minus 2 over 10i. Then for negative 6 over 10, negative number divided by positive number is negative. For 6 over 10, I can divide top and bottom by 2. I can make it 3 over 5. And then for 2 over 10, I can divide top and bottom by 2. Make it 1/5. So there are two solutions. S equal to negative 3/5 plus 1/5 I. S equal to 3/5, negative 3/5 minus 1/5 I. There are two solutions to this equation. There are two solutions to this equation. Next example. 4x squared minus 3x plus 1 equal to 0. How can we solve this equation? If we try to solve this equation by factoring, we can see that the left side here is not factorable. If we try to solve this equation by completing square, I need to divide both sides by 4 first. It generates fraction. It's very hard to solve an equation by completing square. So the best choice for us is solve it by quadratic formula. For quadratic formula, first step, recognize a, b, and c. Here a is 4, b is -3, c is 1. Once we recognize a, b, and c, plug a, b, and c into this formula. So plugging a, b, and c. The formula is -b plus or minus square root of b squared minus 4ac all over 2a. Then simplify. -3, double negative is positive. I get positive 3 plus or minus square root of -3 squared is positive 9. 4 times 4 is 16. I get 9 minus 16. On the bottom, 2 times 4 is 8. Continue. 9 minus 16 is -7. And we know that square root of -7 can be written as square root of 7 times square root of -1. Square root of 7 cannot be reduced. I leave it the way it is. Square root of -1 is I. So square root of -7 can be written as square root of 7 times I. So it's 3 plus or minus square root of 7i over a. That means s could be 3 plus square root of 7i over a. Or s could be 3 minus square root of 7i over a. In general, for complex number, try to write the real part by itself and imaginary part by itself. Put it in standard form. Here we have 3 divided by a, that's the real part. Plus square root of 7 divided by ai, that's the imaginary part. For the other solution, do the same thing. We have 3 over a, that's the real part, minus square root of 7 over a, that's the imaginary part, times I. That's the solution to this equation. There are 2 solutions. Next, let me show you how to solve higher degree equations. How can we solve this equation? X to the power 3 plus a equal to 0. If I solve it like this, if I subtract a from both sides, I get s cubed equal to -a. Then I take cube root on both sides. Cube root of -a is -2. I get a solution s equal to -2. But in general, for a third degree equation, there are 3 solutions over complex numbers. In general, for a third degree equation, there are 3 solutions over complex numbers. How can we find all 3 solutions? Here we only find 1 solution, that's a real solution. How can we find all 3 solutions over complex numbers? In order to find all 3 solutions over complex numbers, we try to solve this equation by factoring. How can we factor this equation on the left side? How can we factor the left side of the equation? Let me remind you the formula. Difference of perfect cube. Sum and difference of perfect cube. When we have a cube plus b cube. When we have a cube plus b cube, the factor form is a plus b times a squared minus ab plus b squared. That's called the sum of perfect cubes. The other one, a cube minus b cube equal to a minus b times a squared plus ab plus b squared. That's called the difference of perfect cube. For a cube plus b cube, we get a plus b times a squared minus ab plus b cube. And for a cube minus b cube, we get a minus b times a squared plus ab plus b squared. This is the sum of perfect cube. X to the power 3 is s cubed. Number A can be written as 2 to the power of 3. And we have addition in the middle. Let's match the formula here. A cubed plus B cubed. So we have s cubed plus 2 cubed. If we apply the formula here, we have x plus 2. Here x represents A, 2 represents B. A plus B times A squared, here A squared is S squared, minus AB. AB means x times 2, which is 2x, plus B squared. Here B is 2, so B squared is 4. If I factor this, if I factor s cubed plus A, using the sum of perfect cubes, I get s plus 2 times s squared minus 2x plus 4. So if I factor this using using the sum of perfect cube, I get s plus 2 times s squared minus 2x plus 4. After factoring, we set both of them equal to 0. Set both factors equal to 0. We set s plus 2 equal to 0, and we set s squared minus 2x plus 4 equal to 0. If I solve the first equation, I can subtract 2 from both sides. I get s equal to negative 2. How can we solve this equation here? For this equation, we can solve it using quadratic formula. We can solve it by completing square. Either way is okay. We can either solve it by completing square, or we can solve it by quadratic formula. Either way is okay. Here, to make it simple, let me use quadratic formula. For quadratic formula here, A is 1, B is negative 2, C is 4. Plug A, B, C into the quadratic formula. S equal to negative B plus or minus square root of B squared minus 4AC all over 2A. Next, if we simplify x, negative 2 is 2 plus or minus negative 2 squared is 4 minus 4 times 1 times 4 is 16. On the bottom, 2 times 1 is 2. Keep simplifying. 4 minus 16 is negative 12. Next, simplify square root of negative 12. Square root of negative 12 can be rewritten as square root of 12 times square root of negative 1. And square root of 12 can be rewritten as square root of 4 times square root of 3. Square root of 4 is 2. We cannot simplify square root of 3, so leave it the way it is. And square root of negative 1 is I. So s equal to 2 plus or minus square root of negative 12 is 2 square root of 3i over 2. That means s equal to 2 plus 2 square root of 3i over 2, or s equal to 2 minus 2 square root of 3i over 2. If s is a complex number, we try to separate the real part and the imaginary part. So write it as 2 over 2 plus 2 radical 3 over 2i. Here, 2 over 2 is 1. 2 divided by 2 can cancel, we get square root of 3i. For the other x here, separate the real part and the imaginary part. We get 2 over 2 minus 2 square root of 3i over 2. 2 over 2 is 1. 2 divided by 2 can cancel, we get square root of 3i. So we got 2 solutions here, plus this solution, we have 3 solutions. S equal to negative 2, and s equal to 1 plus square root of 3i, and 1 minus square root of 3i. There are 3 solutions. In general, when we have a third degree equation, there are 3 solutions in general. Next example, s cubed minus 27 equal to 0. In order to get 3 solutions, we try to solve this equation by factoring. So here, s cubed is a perfect cube. 27 is also a perfect cube. That's 3 raised to power 3. So we have difference of perfect cubes. Factor this using the formula here. S cube minus B cube equal to A minus B times A squared plus AB plus B squared. So here, X represents A, 3 represents B. If we try to match the formula here, X represents A, 3 represents B, then apply the formula. We have X minus 3 times A squared is X squared plus A times B. A times B is the same as X times 3, that's 3X, plus B squared. Here B is 3, so B squared is 3 squared, which is 9. So factor using the formulas of perfect cube, we get this. So X cubed minus 27 can be factored as X minus 3 times X squared plus 3X plus 9. After factoring, set both factor equal to 0. Set X minus 3 equal to 0 and X squared plus 3X plus 9 equal to 0. Solve each equation individually. If we solve for the first equation, I can move 3 over. S3 to both sides. I get S equal to positive 3. That's one solution from here. Next, for this equation, S squared plus 3X plus 9. We can try to solve this equation. We can try to solve this equation using quadratic formula. So use quadratic formula. A is 1, B is 3, and C is 9. Plugging A, B, C into the quadratic formula. Quadratic formula says negative B, which is negative 3 here, plus or minus square root of B squared minus 4 times A times C, all over 2A. Here A is 1. Then simplify. We get negative 3 plus or minus square root of 3 squared is 9. 4 times 1 times 9, that's 36. On the bottom, 2 times 1 is 2. Simplify. Negative 3 stays the same. 9 minus 36 is negative 27. Then simplify. Square root of negative 27 can be written as square root of 27 times square root of negative 1. And square root of 27 can be written as square root of 9 times square root of 3. Square root of 9 is 3. Square root of 3 cannot be reduced, so I leave it the way it is. Square root of negative 1 is I. So square root of negative 27 is 3 square root of 3 times I. So I get negative 3 plus or minus 3 square root of 3 times I over 2. That means S equal to negative 3 plus 3 square root of 3I over 2. Or S equal to negative 3 minus 3 square root of 3 times I over 2. In general, if X is a complex number, try to write the real part and the imaginary part separately. So for the real part here, I take negative 3 over 2. For the imaginary part, write 3 square root of 3 over 2I. That's the real part, and that's the imaginary part. For the other solution, write it as negative 3 over 2 minus 3 square root of 3 over 2 times I. And together we have this solution, S equal to 3, and these two solutions together. We have a total of 3 solutions. In general, for a third degree equation, we have 3 solutions. Those are the 3 solutions to this equation. Next example, S cubed plus 64 equal to 0. This is a third degree equation. In order to get 3 solutions, try to solve an equation by factoring. Here, S cubed is a perfect cube. 64 is also a perfect cube. 4 cubed is 64. 4 times 4 times 4 is 64. So this is the sum of perfect cubes. The formula for the sum of perfect cube is A cubed plus B cubed equal to A plus B times a squared minus ab plus b squared. So here try to match. We have s cubed plus 4 cubed. So x represent a, 4 represent b. Then apply the formula, we have x plus 4, a plus b. X represent a, 4 represent b. Times a squared, a is x, so I get s squared, minus ab. ab is x times 4, which is 4x. Plus b squared, here b is 4. 4 squared is 16. So after factoring, we have s plus 4 times s squared minus 4x plus 16 equal to 0. Then set both factors equal to 0. Set s plus 4 equal to 0. Then set s minus 4x plus 16 equal to 0. Solve each equation individually. For the first equation, I can subtract 4 from both sides. Okay, s equal to -4. That's a solution for the first equation. For the second equation, we can try to solve it using quadratic equation, quadratic formula. Quadratic formula, first of all, recognize a, b, and c. Here a is 1, b is -4, c is 16. Quadratic formula is -b plus or minus square root of b squared minus 4ac all over 2a. Then simplify. -4 is +4 plus or minus square root of -4 squared is 16 minus 4 times 1 times 16 is 64. On the bottom, 2 times 1 is 2. Then simplify. We get 4 plus or minus square root of 16 minus 64 is -48. Next, simplify negative square root of 48. Square root of -48 can be rewritten as square root of 48 times square root of -1. And square root of 48 can be rewritten as square root of 16 times square root of 3. 16 times 3 is 48. Square root of 16 is 4. Square root of 3 cannot be reduced, so I leave it the way it is. Square root of -1 is I. So square root of -48 is 4 square root of 3i. So we get 4 plus or minus 4 square root of 3i over 2. That means s equal to 4 plus 4 square root of 3i over 2. Or s equal to 4 minus 4 square root of 3 over 2. Next, if s is a complex number, try to write it in standard form. That means write the real part and the imaginary part individually. For the real part, 4 divided by 2 plus, that's the real part. For the imaginary part, right, 4 square root of 3 over 2 I. Then if we simplify, 4 over 2 is 2. 4 over 2 is 2. I get 2 square root of 3 I. For the other x, separate the real part and the imaginary part. We get 4 over 2 minus 4 square root of 3 over 2i. Here, 4 over 2 is 2. 4 over 2 is 2. Like, square root of 3 stays the same. I stays the same. So we got 2 solutions here. Plus this solution, we have a total of 3 solutions. X equal to -4. S equal to 2 plus 2 square root of 3i. And s equal to 2 minus 2 square root of 3i. There are 3 solutions. In general, for a third degree equation, there are 3 solutions. Next example, as cubed minus 1 equal to 0. This is a third degree equation. In order to get 3 solutions, we try to solve the equation by factoring. So here, a is a perfect cube. 2 times 2 times 2 is a. So a is 2 cubed. S cube is also a perfect cube. So as cube can be written as 2x to the power of 3. And same thing, number 1 is 1 cube, 1 times 1 times 1 is 1. This is the difference of perfect cubes. The formula for difference of perfect cube is a cube minus b cube equal to a minus b times a squared plus ab plus b squared. That's the formula for difference of perfect cube. Now try to match. We have 2x cube minus 1 cube. That means 2x represent a, number 1 represent b. So apply the formula, we have 2x minus 1 times a squared. A squared means 2x squared. 2x squared means 4x squared. Plus a times b. A times b means 2x times 1. 2x times 1 is 2x. Plus b squared. Here b is 1. 1 squared is also 1. So after factoring, we have 2x minus 1 times 4x squared plus 2x plus 1 equal to 0. Then we set both of them equal to 0. We set 2x minus 1 equal to 0, and we set 4x squared plus 2x plus 1 equal to 0. Solve both equations individually. For the first equation, I can first of all add 1 to both sides. Make 2s equal to 1. I can first of all add 1 to both sides. And then I can divide both sides by 2. If I divide both sides by 2, s is half. For the second equation, this is a quadratic equation. We can try to solve it using quadratic formula. First step, try to recognize a, b, and c. Here a is 4, b is 2, c is 1. Apply quadratic formula. The formula is negative b plus or minus square root of b squared minus 4ac. 4 times a times c all over 2a. Then simplify. We get negative 2 plus or minus square root of 2 squared is 4 minus 4 times 4 times 1 is 16. On the denominator, 2 times 4 is 8. Then simplify. 4 minus 16 is negative 12. Square root of negative 12 can be written as square root of 12 times square root of negative 1. And square root of 12 can be written as square root of 4 times square root of 3. Square root of 4 is 2. Square root of 3 cannot be reduced, so we leave it the way it is. Square root of negative 1 is I. So square root of negative 12 is 2 square root of 3i. So x is negative 2 plus or minus 2 square root of 3i over a. If s is a complex number, try to separate the real part and the imaginary part, write in standard form. So here x equal to negative 2 plus 2 square root of 3i over a. S equal to negative 2 minus 2 square root of 3i over a. If we separate the real part and the imaginary part, we get negative 2 over a plus 2 square root of 3 over a times I. Here, negative number divided by positive number is negative. 2 over a can be reduced as 1 over 4. Same thing here, 2 over a can be reduced as 1 over 4. So I get square root of 3 over 4i. For the other x, do the same thing. S equal to negative 2 over a minus 2 square root of 3 over a I. Negative 2 over a. Negative number divided by positive number is negative. 2 over a can be reduced as 1 over 4. And same thing, for this 2 over a, it can be reduced as 1 over 4. I get square root of 3 over 4i. So here we get 2 solutions for x. And plus this solution here, we have 3 solutions of x. S equal to half. S equal to negative 1 over 4 plus square root of 3 over 4i. S equal to negative 1 over 4 plus square root of 3 over 4i. There are 3 solutions to this equation. Next example, x to the power 4 minus 16 equal to 0. How can we solve this equation? We can first of all add 16 to both sides. If we add 16 to both sides, we get x to the power 4 equal to 16. And then we can take the fourth root on both sides. When we take an even root, always add plus or minus sign. So we get s equal to plus or minus, the fourth root of 16 is 2. Here we get s equal to 2, s equal to negative 2. But this is a 4-degree equation. In general, it should be 4 solutions. Here we only get 2 solutions. That's not enough. This is a 4-degree equation. In general, we should get 4 solutions. Here we only get 2 solutions. That's not enough. How can we get 4 solutions? How can we get all 4 solutions? We can try to factor first. In order to get 4 solutions, we can try to factor first. The formulas: difference of perfect square, a squared minus b squared equal to a plus b times a minus b. Here, x to the power 4 can be written as x squared squared. 16 can be written as 4 squared. So imagine the form here. X squared squared minus 4 squared. Here, x squared represents a. Number 4 represents b. If we factor using difference of perfect squares, we get s squared plus 4 times s squared minus 4. Use difference of perfect squares. We get x squared squared minus 4 squared, which is s squared plus 4 times s squared minus 4. After factoring, set each of them equal to 0. Set s squared plus 4 equal to 0, and set s squared minus 4 equal to 0. Then solve each equation individually. For the first equation, I can first of all move 4 over. If I move positive 4 over, positive 4 becomes negative 4. And then take square root. When we take square root, always add plus or minus sign. I get plus or minus square root of negative 4. Square root of negative 4 can be written as square root of 4 times square root of negative 1. And we know that square root of 4 is 2. Square root of negative 1 is I. So square root of negative 4 is 2i. S equal to plus or minus 2i. That means s equal to positive 2i or s equal to negative 2i. We have 2 solutions here. Solve the other equation. Add 4 to both sides. S squared equal to 4. And then take square root. S equal to plus or minus square root of 4. And we know that square root of 4 is 2. That means s equal to 2 or negative 2. Together we get 4 solutions. This is a 4-degree equation, and we get 4 solutions. So that's all the solutions to this equation. Those are all solutions to this equation. Next example. X to the power 4 minus 25 equal to 0. X to the power 4 minus 25 equal to 0. So this is a 4-degree equation. In order to get 4 solutions, try to factor left side first. So 4 squared, x to the power 4 is x squared squared. 25 can be written as 5 squared. So they are both perfect squares, and that's the difference of 2 perfect squares. Imagine this formula here. So x squared represents a, number 5 represents b. If we use the formula, we have a squared plus b times a squared minus b. After factoring, set both factors equal to 0. So we have x squared plus 5 equal to 0, x squared minus 5 equal to 0. Solve each equation individually. For the first equation, I can first of all subtract 5 from both sides. I get s squared equal to negative 5. Then, in order to get s by itself, take square root. S equal to plus or minus square root of negative 5. And we know that square root of negative 5 can be written as square root of 5 times square root of negative 1. Square root of 5 cannot be reduced, so I leave it the way it is. Square root of negative 1 is I. square root of negative 4 is square root of 5i. That means s equal to plus or minus square root of 5i. That means s equal to square root of 5i, or s equal to negative square root of 5i. For the other equation, I can add 4 to both sides. I make s squared equal to 5. Then if I take square root, s equal to plus or minus square root of 5. Square root of 5 cannot be reduced. So the answer is s equal to square root of 5, or s equal to negative square root of 5. Together we get all 4 solutions. Together we get 4 solutions. This is a 4-degree equation, and we get 4 solutions. Those are all solutions to this equation. Next example, x to the power 4 minus 4x squared minus 4 equal to 0. This is a 4-degree equation. It must have 4 solutions. We can try to solve this equation by factoring. This is a trinomial, and there's no leading coefficient. We can draw 2 premises. X to the power 4 can be separated as s squared times s squared. Can we find 2 numbers that they multiply to be negative 5 and add to be negative 4? Can we find 2 numbers that they multiply to be negative 5 and add to be negative 4? We can try negative 5 and positive 1. When we multiply, we get negative 5. When we add, we get negative 4. After factoring, set each of them equal to 0. Set x minus 5 equal to 0, s squared plus 1 equal to 0. Then for the first equation, I can add 4 to both sides. I get s squared equal to 5. Next, I can take square root on both sides. S equal to plus or minus square root of 5. Square root of 5 cannot be reduced, so that's the solution. S equal to square root of 5, or s equal to negative square root of 5. For the second equation, I can subtract 1 from both sides. If I subtract 1 from both sides, s squared equal to negative 1. Then take square root. S equal to plus or minus square root of negative 1. And we know that square root of negative 1 is I. So s equal to plus or minus I. That means s equal to positive I, or s equal to negative I. This is a 4-degree equation. We get 4 solutions. So those are all solutions to this equation. In general, for a 4-degree equation, we should have 4 solutions. Next example, x to the power 4 minus 2x squared minus 3 equal to 0. This is a 4-degree equation. In order to get 4 solutions, let's factor first. This is a trinomial with no leading coefficient. So we can first of all draw 2 premises. S to the power 4 can be separated as s squared times s squared. Next, try to find 2 numbers that they multiply to be negative a and add to be negative 2. We can try 4 and 2. Negative 4 and positive 2. Negative 4 times positive 2 is negative a. And negative 4 plus positive 2 is negative 2. So put these 2 numbers in the parentheses. After factoring, set each of them equal to 0. We can set s squared minus 4 equal to 0, and s squared plus 2 equal to 0. Solve each equation individually. For the first equation, I can first of all add 4 to both sides. I get s squared equal to 4. Then I can take square root on both sides. Square root of 4 is 2. That means x equal to either positive 2 or negative 2. We get 2 solutions from this equation. For the other equation, I can subtract 2 from both sides. So s squared equal to negative 2. Next, I can take a square root. S equal to plus or minus square root of negative 2. Square root of negative 2 can be written as square root of 2 times square root of negative 1. And we know that square root of 2 cannot be reduced. We leave it the way it is. Square root of negative 1 is I. So square root of negative 2 is square root of 2i. So s equal to plus or minus square root of 2i. That means x is either positive square root of 2i or negative square root of 2i. Together, there are 4 solutions. This is a 4-degree equation. If we get 4 solutions, they are all solutions to this equation. Next example, x to the power 4 plus 5x squared plus 4 equal to 0. This is a 4-degree equation. In order to get all 4 solutions, we try to solve an equation by factoring. This is a trinomial with no leading coefficient, so I can separate x to the power 4 as s squared times s squared. Next, try to find 2 numbers that they multiply to be 4 and add to be 5. We can try positive 4 and positive 1. 4 times 1 is 4, and 4 plus 1 is 5. Put these 2 numbers in the parentheses. We get s squared plus 4 times s squared plus 1. After factoring, we can separate. Write it as s squared plus 4 equals 0 and s squared plus 1 equals 0. Then solve each equation individually. For the first equation, I can first of all subtract 4 from both sides. I get s squared equal to negative 4. Next, take square root on both sides. I get s equal to plus or minus square root of negative 4. Square root of negative 4 can be written as square root of 4 times square root of negative 1. We know that square root of 4 is 2. Square root of negative 1 is I. So square root of negative 4 is 2i. That means s equal to plus or minus 2i, which means s equal to 2i or negative 2i. So we got 2 solutions for this equation. For the other equation, I can subtract 1 from both sides. I get s squared equal to negative 1. Next, I can take square root on both sides. If I take square root, I get plus or minus square root of negative 1. And we know that square root of negative 1 is I. That means s equal to I or negative I. So this is a 4-degree equation. We get all 4 solutions here. Next example, x to the power 4 plus 5x squared plus 6 equal to 0. Again, this is a 4-degree equation. In order to get all 4 solutions, we have to solve an equation by factoring. This is a trinomial with no leading coefficient, so I can separate x to the power 4 as s squared times s squared. Put it in the parentheses. Next, try to find 2 numbers that they multiply to be 6 and add to be 5. We can try 2 and 3, positive 2 and positive 3. 2 times 3 is 6, and 2 plus 3 is 5. Put these 2 numbers in the parentheses. Get positive 2 and positive 3. After factoring, separate. Set both of them equal to 0. We get s plus 2 equal to 0 and s squared plus 3 equal to 0. Then solve each equation individually. For the first equation, I can subtract 2 from both sides. I get s squared equal to negative 2. Then take square root. S equal to plus or minus square root of negative 2. Square root of negative 2 can be written as square root of 2 times square root of negative 1. Square root of 2 cannot be reduced, so leave it the way it is. Square root of negative 1 is I. So s equal to plus or minus square root of 2i. That means s equal to square root of 2i or s equal to negative square root of 2i. So we got 2 solutions for x from this equation. From the other equation, I can subtract 3 from both sides. I make s squared equal to negative 3. Next, take square root on both sides. S equal to plus or minus square root of negative 3. Square root of negative 3 can be written as square root of 3 times square root of negative 1. We know that we cannot reduce square root of 3, so I leave it the way it is. Square root of negative 1 is I. So s equal to plus or minus square root of 3 times I. So we got 2 solutions here. S equal to square root of 3i or s equal to negative square root of 3i. Together we have 4 solutions, and this is a 4-degree equation So get all solutions to this equation.